Hello, everybody. Enjoying the conference so far? Yes. Ah, good, good. Well, let's change the trend with this presentation then. All right. I have a few slides. It's mostly going to be a live coding session with all the problems that can generate. I hope there are not too many. A little bit about me. That's my Twitter handle. You might know me for like a weekly blog post about Clojure that is sent out every week. Yeah. If you don't know, it's a very short thing. It's getting some traction, and it's quite useful, I think. All about Clojure and libraries and standard libraries and everything. I'm lead developer working at a London-based company called WGSN that is doing fashion forecasting. Little warning, there will be Clojure. We don't have time to look into the language problems, so you need to know a little bit of Clojure to follow this. A little bit of background, what we're talking about. So there were a few attempts already in the Clojure library to introduce parallelism. The first one, probably PMAP, introduced with 1.0, is mapping each element of a collection into its own thread or future, sending them out for computation, and they're collecting them back after the results. It is a simple approach. It has limitations, especially if the function is not doing a lot of work. You're wasting mostly time with the parallelization and the threading, sending out those as like workers, external workers. Instead, if your function is doing quite a lot, it's quite heavy, then that could be a good approach. This for mapping specifically. A deprecated form of reducing in parallel was introduced at some point later. This is based on the fork join framework, JSR 166, that was introduced officially in the JDK 7. And this is just a wrapper around that, so it's not doing anything Clojure side. It's just mapping collections into a parallel array of the library and waiting for the results to come back. Another experimental fork join was done with PVMap. It's an experimental branch still visible from GitHub, and that was a better attempt, like a better result, I think, at the attempt. Since like the collection manipulation, the splitting into multiple pieces was done on the Clojure side and then sent off to fork join. And reduce is kind of accumulating all of the experience into like a more composable and clean interface, and this is what we are going to see today. In general, you will see also functional property decomposition, some functional items, and a few refactoring moves that might be helpful also outside reducers. Feel free to interrupt anytime. I'll try to go fast because there is no lot of time. What is our goal? We would like to see how reducers in Clojure work by basically rewrite them from scratch. And we'll start with three simple goals. One function is our goal that has a similar interface to reduce, so we are not changing semantic. We use what we know, and can accept transformations other than reduce. So I can apply other functions on top of reduce, which is the final what is generating the results. That means like incrementing. That means manipulating a map depending on your context. And hopefully efficient parallelization. So all these transformations and the reduce operation should happen like in the same loop. I shouldn't need to send off for parallelization the map, then wait for the results, and then send off the reduce and wait for the results. It should all happen in the same thing. So let's get started. Quick check. Can you see good? From far behind as well? Good, so we are going to use definitely some sort of collection for the entire length of the presentation. So we're going to create something we can use. So keep an eye on the bottom bottom left corner for results to appear, and this should work. Oh, yeah, we are not starting good, right? Yeah, this will happen. So we are searching for something like this. Parallel reduce that takes maybe, this is an example, associative plus a seed of some sort, so as I can get the key right, and it's applied on collection. This, of course, does not exist. Let's create that. And we'll start working on this one. Takes an associative, some function, a seed, and a collection. Okay, and just for see if everything is hooked up, just invoke reduce. So for 4950 is what we get. I'll save it here just to see if everything is coherent. So what if we want to introduce parallelization in this? Then turns out it's not that difficult. Yeah, there are some complexities that we are going to skip, but it's going to be something like this. We could try to split the collection in two parts. And then concentrate on each of the splits. So stakes up back of the collection from 0 to the split, and collection so back to this, from the split to the rest, and forgot the parenthesis. And once, no, it's matching another one. Yeah. Once we have this, what we should do is when we need to decide when, but when we reach a leaf, let's say this is completely arbitrary, so the collection should be small enough to be sent off to a worker, let's say 50. That depends on the number of cores you have available, so the number of workers, and mainly the kind of computation you're doing. So you need to find out what is the best sub-splitting, where you need to stop. So when you have this, well, okay, that is when it's time to do the actual reduce. If you are not at that point, then you keep on invoking. So you produce it again. You see it on the first collection and on the second. While I'm using G, I need to combine those two splits when the results come back. One way of doing that is using the same associative function you're using for reduce. That's not always the case. That's why in the reducers framework, you can pass in your combining function and override the behavior. But in this case, it's simple enough. Plus can bring together the two results. All right, so it's time to try. Oops. Here we go. So it's still working as expected. It's not going in parallel, but we achieved the functional composition. Then this is where you need to do something. And if you look at the reducer sources, you will see that here is where we are using the fork join to send off task for each one of the two sub-collections and getting back results and combine them. Cool. Are we happy? Yes, but yeah, we achieved some sort of parallelization. But what if we don't want to do just a reduce in this operation? And let's say I want to do, let's increment on each element of the collection also. So that is going to change the result, of course. But if I do this, the mapping, so like incrementing each element of the collection is not going in parallel. Is applied before and then is sent off to the parallelization. So this is not what we want, so it's not efficient. Well, we can simply take maybe control of that plus, and if we take control of that plus, then we can decide what to do with the two elements of the computation. This is still the same thing. Oh, wait. Now I'm going to remove the increment here. And I can add it here. So each time I have an element, I increment it. Numbers are different, you will maybe notice. And this is not due to what we are doing. So yes, so it's because we need to introduce a little bit more complexity if you want the increment of the reduce to be the same in both places. And this is depending on the seed and the way the computation is done. There's a way to fixing it. I'm not going to fix it now. But it's generally is doing what we expect, is incrementing and summing all the numbers up. All right, are we happy? Yes, but we're not talking about plus or incrementing every time. So maybe we should just make sure that we can generalize this thing. So it is true that I can always wrap a function into another function without altering the results, but I need to invoke it now. No, not this, okay. There must be a parenthesis, right? Yes. Still the same. So now I can extract the operation here. Let's call it F. So instead of inc, I'm passing that down, and I can decide if this is going to be an inc or is it going to be something else. Good. Same for plus. It's not going to be always a plus, the kind of reduction we are doing. So we can apply the same principle again. Wrap it. Empty for the moment. Then we need to invoke it twice. And we can extract. Let's call it G. And we now need to pass it down. Yep. Is it better? Yes, it's general. But with this reduce at the moment, we kind of went away from the original reduce semantic. So we are invoking something on this reduction operation on the plus and then passing down the collection. Wondering if we can go back to what we are used to, like to mapping the collection with an increment and then reducing it. So it turns out that we can push this plus increment here down to the collection. And the way this can be done is because reduce is, the reduced implementation is based on protocols, and we can just reify that protocol so that we take control over the reducing operation on that collection, and we can do whatever we want. Let's see if I can illustrate this. Let's create a reducer function. The names start to go in the right direction as well. That takes like a transforming function and the collection, and we reify here over core Clojure protocols called reduce, which is where this thing lives. And this protocol has one function with two arities, and we need to provide those. Call reduce with implicit collection coming in of f, which is the function, and call reduce implicit thing coming in with a seed. So one is with a seed, the other is not. All right, so we need to do something here. We don't need to do like fancy stuff. We can just invoke the normal call reduce, which is defined for vectors and the other types. But we can apply our transformation in the mix, which is what we want. So call reduce of oh yeah. Yeah, thank you. That was about to throw a nasty error to catch? Good, thank you. All right. Call reduce of collection and the transformation fx applied to f. So f is our associative function, and we are taking that function and do what we did in our example before. So we are applying some transformation on top of it. And we got a seed here that we need to pass. So that could be 0, but that is valid for plus and maybe other associative functions. It's not true for everything. One convention we can take is that we can invoke the reducing function without arguments and let that function return us what should be considered the seed for the kind of operation. This is not always true. I'm just trying to reduce the complexity. And the reducer framework, what is done here is that your combining function that is giving this result instead of the reducing function. But we can use it here to reduce a little bit complexity, so I don't need to send around the combining function. And we need something similar, but we know what the seed is here. Seed. And we just pass it down. So is closing not and that. Okay, so this is going to throw an error. Oh, not this one though.
You have one extra parenthesis.
Oh, okay. This one, right? Let's see if it's balanced. Good. Yeah, still working because we are not using it. Let's try to use it now. So now that we reified the protocol, we can push down to the collection what we need. So we transform this collection with this reducer function, passing down what we want. Like this should be incremented in this case, and we don't need this anymore. Okay, so the problem now is that this produce function that we created doesn't know what to do with a reified object. So the type of this collection has changed. It used to be like some sort of vector. But now that we are reifying it this way, it's turning back as another type. So it's throwing that I cannot count on this kind of collection, which is not a collection, it's a reified collection. We need to do something similar for produce, basically. We need to create some protocol and make sure that when we are reifying on the call reduce protocol, we are also reifying on our protocol so it takes the collection instead of the reified collection. How do you do that? Well, we need a protocol. Let's create the protocol. Protocol. And we call it maybe call parallel. And this has one call parallel thing that is invoked on a collection, some function g, and a seed, and is implemented using our produce. Oh, sorry. It's not implemented here. This is just the definition of the protocol, and we are going to reify the protocol here. So our collection, call parallel. I'm going to explain what I'm doing in a second. This is implicit argument. This is some function g. This is the seed. And what we need to do is call our produce. And now we pass the collection that is not the reified version of it, which is coming down from the parameters in the main function. And we still need to transform g, and then we pass the seed. I'm not sure if our produce is taking that order of arguments. No, it's taking g, seed, and collection. So we need to do this, g, seed, and the collection goes at the end. So that we've done that, Let me see, call produce. Oh yes, now that we have done that, we need to invoke the protocol instead of produce, which is what knows what to do with the reified collection, which is what we are passing. And call produce in this context, yeah. Yeah, that's correct. And I'm invoking the wrong method name, the function name. Call parallel protocol, not found. I'm probably doing some strange thing here. Call parallel. Yeah, this is expected. Bear with me a second. I usually spot it. Produce? Why produce here? Oh, yes. It's called produce, G seed and collection. G seed and the collection. I'm invoking the protocol method and I'm using the reducer. Can you spot anything?
What's the first parameter there? You don't want to be dispatching on the plus, do you?
Yeah, all right, exactly. I forgot this. We had to invert, thanks. We had to invert the parameters order. So we now got the plus here and the seed at the end. And it's probably still wait a second. Why I'm using plus here? Thought it was plus here. Sorry, say it again. Here? Oh, this G is passed down here. So collection G seed. Let me see. All right, I'm calling call parallel, which is correct, on what it says here in the protocol. So it takes a collection, a function, and a seed. I have the collection here, which is going down through the reducer with the transforming function, and then it requires the seed and the operator. I'm calling? Here? Is correct, I think. Reducer is taking the transforming function and the collection and is refining call parallel. And
At the bottom, the plus and zero should first of all be the other way around, right?
So I'm invoking this protocol collection G and seed. Oh yeah. G and seed. Too bad. Then this is saying cannot be cast. So yeah, it seems that I'm still inverting somewhere the order, and this one is getting the wrong order. So this is G, the seed, and the collection. Am I doing that? G, seed, and the collection. And this is correct. Call reduce. Oh man. Okay.
Why is that becoming fx and sheet? How is that?
Fx is ing and G is plus.
You have two calls to write by in a row. I think you want
Why I'm calling? Because, yeah, that's ink.
Ink and G is plus,
Yeah.
so you can't ink the function.
Collection is reified here. All right. I don't want to like. I thought I could spot it. If I cannot spot it, I'll probably just move forward and see if I can fix it. Unfortunately, I tried my best not to get lost during the presentation, and yeah, things that happen, I suppose. And
So on 30, should that plus operator be the plus function you defined on 27?
So the reducer, yes, it should.
You have two calls to ratify. You're only returning the last one.
You're thinking to reduce this.
That I think is correct.
You want to combine them. Yeah, you want one result from that function.
Yeah, because you need to satisfy both for the false, but you're only satisfying one of the thing that you're returning.
Oh, so it may be that.
So delete that word ratify. Pop off that thing.
Too bad. That seemed a good thing because it was like I made a mistake with parentheses. So okay. So wait.
Delete that word. Delete that word and delete that parenthesis to your left. Yeah. That right.
I'm pretty sure I was using both of them, but yes, it's the same. Class is sending them down the wrong order. This is what happening. Is trying to use plus. Is trying to is receiving plus as the seed here in the produce. For some reason I don't understand. There might be an inversion somewhere that I'm not seeing at the moment. All right, I just want to move forward.
It's not that you should use only the G there.
What is the line? Sorry.
We have FX G, it's only the G.
Sorry.
The ink is already used on the other product, isn't it?
The ink is already used where?
So line 22 you're incrementing, and line 25 you're incrementing.
Yeah,
So you're applying G function in two places.
just apply G there.
I'm listening to you because. There you go. All right. But it's not applying the increment now, right? I
Yeah, don't you want to maybe FX the whole result if you reduce the not G of G?
I'm pretty sure it is the transformation applied to G. Is that I cannot spot where I'm doing like something odd with the arguments. I'm inverting them. I'm also wondering if it's not the cache, right? That is maybe getting.
Well, you don't want to ink plus. You want to produce a function that is the result of doing both.
Right.
But that's not.
I'm pushing that down to the collection. So if I invoke call parallel, which is defined here, and stick in the collection, and G, and a seed, it should work? Yeah, unfortunately it's not. Let's move on. I don't think there is time to fix it, and I already lost enough time. All right, let me find where we can move without this. Well, basically, so you need to bear with me, and I cannot execute it and show you the results. But do we like this form? Not really. The problem with this is that it's still inverting the order of the arguments compared to the normal reduce, but this is easily fixable. if we just wrap it into something that can be called fold, that takes some G seed in the collection. And if we do this inside, called parallel with this stays out, with G that is coming from the above, and plus and 0. We can invert this and just invoke fold on plus, the seed, and the reduced collection that knows how to map. Yeah, and this should be really call whatever is the protocol saying. And I think this goes, no, it goes to the beginning. When we obtain the form of fold that we want, we should verify we're still happy. So we are able to map a transformation on the collection. So we push that into the collection. We are sorry, caps lock. Something happened here. Okay. We kind of obtain an API that is similar to reduce with fold. What can we do now? Well, there is a similar process, and probably I have to skip how to do it, to apply other kind of transformations. So we were talking about an increment in this case, but filtering is not very different from this. Filtering can be applied just by creating a function here. Probably I see what I did wrong, but there's no time. Similar to this function plus, but where instead of applying the transformation every time, we verify a predicate, and then we apply it or not, deciding based on that. And with that filter in place, we can also compose them, because at this point here, this reducer can be composed with comp or something similar in order to obtain a similar result. And I think it's pretty much it. There was something else I could show you. So this is basically, if you look inside the reducers library, the source file, you will see more or less what this was done in the right way, plus including all the complexities that I had to skip to like make it quicker. But it's basically, the principles are all there. You just wrap the collection into a reified version of it that can support the concatenation of transformation you need. One use I can show you of reducers, if you want to play with them, is on a library I created, which is called PWC, which is a parallel version of WC, the counting utility in Unix systems. If you brew tap that tap's location and then you brew install PWC, you will have it available. And when you have it available, it's just going into some, maybe find some big file and then PWC on it to like obtain the same results that PWC is, the sequential WC is giving you back. There is an additional printing frequencies thing. So this is basically an application of reducers applied to the word, the usual word count problem. I can give you, see there are other 2 minutes, I can give you an idea of how that it was done. This is the entry point, but what basically this is doing is using the reducers library with a combination function and a combination of other mapping and transformation on top. And basically, the important part of it is this reducing counter, which is the transforming function on top of the reduce that is going to happen next, which is taking line by line, is splitting the line into words, and then is counting them up into a map that is then the result of the reducing at the end. And I think it's pretty much it. Of course, I'm sorry it happened. Was kind of like one of the expected results. I took the challenge. I usually like to do it, and sometimes I screw up pretty badly. There are any questions I can answer?
Have you posted your PwC code anywhere?
Oh yes, it's resources is on GitHub, and this is a few links. But if you look up my Twitter handle on GitHub, you'll find PwC in my projects. But that is the link. I also wrote an article for the SD Journal with a little bit of the concepts I explained today. And there's a little bit of history as well. So if you want a little bit more background, it's available for free. I think you need to register, but it's free. Give an email. Any other question?
How much faster PwC than WC?
It's not faster at the moment. One reason I think I can make it faster, but WC is really, really hard to beat. It's not faster because I'm also doing frequencies. And even if I skip the calculation, the real calculation of the frequencies, I'm still introducing a little bit of overhead to keep the count of each word. And the other thing is there are optimizations I still need to do. It's like a work in progress side project. And the two main important one is I shouldn't use any regesp. You might have seen that here. Those are, if you fire up a profiler when the PwC is running, you will see that is what is taking most of the time at the moment. And to split a sentence into words in a simple way, you can do without regesps. And other things are putting types, so I avoid reflection overhead by Clojure. Just I'm talking about strings all the time. So it's not faster. It's 10, 15 seconds slower at the moment. Planning to make it faster. I hope so. Any other question? All right. Thank you. Have a good lunch.